This video is going to take you through how to do a quadratic regression in Desmos once you know 3 points. If you've done regressions in Desmos before, then this will be partly a review. If this is your first time doing regressions in Desmos, then just know that you can apply this to other function families as well. Over here on the left where you see the plus sign, if you click on that, it will give you the option to add an item. And in this case, we are going to add a table. That's going to allow us to plot the points that we know are on our function or on our graph. So for this example, we are going to use the points -1, 5, 3, -3, and 7, 5. And you can see over here that Desmos plots those as I enter them into the table. Now, if it turns out that you have points that you can't see because the numbers are too big or too small, you can always click on that zoom fit. And you'll notice that when I did that, it actually adjusted my viewing window so that I could see the points a little bit better. So that's really, really valuable if you have points that are really big or really small and they're not on the regular coordinate plane that you have there. Now, to do the regression, we're going to click into the second line here. And as with other regressions, we are going to use not x and y, but we're going to use x1 and y1. And the reason for that is we want to tell Desmos to reference the table. And the table is labeled x1 and y1, and Desmos needs to know that that's what we want it to look at. So we'll start by doing a standard form regression. So standard form is y equals ax squared plus bx plus c. So I'll say that again just so you can kind of catch up. It's y equals ax squared plus bx plus c. Now, in order to do the regression, though, we don't want to use y. We want to use y1. If you just type y and then the number 1, it will automatically make it a subscript. And it tells you, okay, we are looking at a 3-element list right there. Now, instead of using an equal sign, though, we use the little tilde. You can find that near the number 1 on your computer. Okay, it's a little bit trickier if you're using the app. And I just realized the sky is a beautiful pink out right now. We're expecting a hurricane at the time that I'm recording this video. So I don't know what that means, but the sky is a beautiful shade of pink. Okay, sorry about that digression. So we use the tilde instead of the equal sign, and now we will type in standard form. So we will say ax1. So it's not ax squared, it's ax1, and then we want to square that. I kind of messed that up earlier when I was practicing with this. Plus bx, and again, you want bx1, not just like bx, and then plus c. And what you can see is that we have a beautiful parabola that goes through those points, and we have the numbers that would go in the equation for a, b, and c. So I'm going to take a moment and write that down. So I have a is 1/2, so you would have 1/2 x squared, minus b is -3, so minus 3x plus 1.5. And that's the equation that fits those points. Now, what's really cool about Desmos is that you're not restricted to just standard form. You can do your regression in other forms as well. So, and down here in line 3, we will do a regression from vertex form. Okay, and if you look at the parabola over here, we can see where the vertex is. So hopefully our regression will corroborate that. Vertex form will use y1, then we use the tilde, a, and then vertex form, remember, is x minus h all squared plus k. So x minus h all squared plus k. So I will do not just x minus h, but I need x1 minus h. And then we need that squared, and then plus k. and it will tell us what the h and the k values are. Now, one thing that you want to notice, before I had this regression on here, I can actually hide that by clicking on it. The parabola was green, and then when we graphed the black one, notice that it went right on top of the green one, okay? What that means is that they are the same parabola, just two different forms of that equation. And if I scroll down, you can see what those values are. So we once again have a is equal to 1/2, x minus 3, that would be our h, all squared, and then another minus 3. And that's where our vertex is. Okay? And we have one other form of quadratics that we use a lot, and that is factored form. So down here in line 4, we will do the regression with factored form, which, if you remember, is you have to have the a, again, just because you need to have the room for the compression or the stretch, and then it would be x minus p, x minus q. So we'd be looking for the x-intercepts, which are going to be here and here, if you can see where my mouse is, okay? Here and here, not in nice places. So I am expecting some kind of yucky looking decimal for that, okay? So we will have y1, then the tilde, a, x, now again, not x minus p, but we need x1 minus p, and then x1 minus q. And if you look at what happened, the red graph went right on top of the black one, which went right on top of the green one. And so what we're dealing with here are 3 different forms of the exact same parabola. And we can look down there, and as predicted, well, first of all, notice that the a value is the same in all of these, but as predicted, we got some nasty numbers for our p and our q. Okay, so this was the q value, 0.55. Over on the left, it says 55051. This is rounding it to 0.551. And then over here, 5.449. And we see over here, it's 5.44949. And this actually happens a lot where you have, like you can have nice numbers for the vertex, but you'll end up with terrible numbers for your, x-intercepts, and vice versa. Sometimes you can get, ones that have nice y-intercepts and x-intercepts and like a nice vertex too. But all right, and that is the demonstration for how to do the regression for a parabola once you have 3 points using all 3 forms. I hope this video was helpful.